Hello everyone. We want to talk about the concept of wettability. We talked about the interfacial tension and surface tension in previous videos. One of the implications of interfacial tension is the concept of wettability, and wettability is defined as the tendency of the one fluid to spread or adhere over the surface of a solid. For example, assume that there are two types of fluids available on a solid surface, and this solid surface, for example, it's our rock, our reservoir rock, and there is water and there is oil, right? So the question is, which of these two fluids have higher tendency to be adhered to the surface or spread over the surface? Now, the fluid that has higher tendency to be spread over the surface and to adhere to the surface of the rock is called the wetting phase. And if that happens, for example, in this case, I have water spreading over the surface. This rock is called a water wet rock. So this is basically the concept of wettability, and why do we need to study it? Because it's important in production of fluids from the reservoir, because we have multiple fluids inside our reservoir. Usually we have water, oil, and gas. It's a multi-phase system, and these fluids are interacting with the rock, with the reservoir rock, and all these interactions basically is the important factor in how much oil we produce from these reservoirs. So we need to understand the interaction between our fluids and the rock in order to be able to predict, or sometime in enhanced oil recovery methods, to modify the properties of the rock to be able to produce more fluids. If you look at this picture, you see that we have water and we have oil, and what we want to do here is to write the force balance. So what type of forces are acting here? And remember, we talked about the forces that are in the boundaries of two different phases. So those are the forces that we are interested here, and you see that there is oil, there is water, and there is a solid surface. So each two of these phases could have that interfacial tension energy, or force per unit distance, basically, and that's what we want to write. So if you look at this picture, you see that there is oil and solid interaction, the interaction between these two is shown with this brown sigma OS. O represents oil, S represents the solid, so that's one force in the boundary of oil and solid. There is a water solid interaction with the blue arrow, and it is shown with sigma WS. So this is sigma WS here, and this is sigma WS, this is sigma OS. Between oil solid, and this is between water and solid, and then there is another interaction between water and oil, and that's at the boundary of these two phases at this point that we are writing our equation for. So and that's sigma OW, means that the interfacial tension between oil and water. We show the interfacial tension with sigma, and this is the sign that we're going to use. So now, if we want to write the force balance in the x direction, we have to decompose this sigma OW into x-axis and y-axis, and then use the x-axis component, right? So the x-axis component of this force is sigma OW cosine theta. Now, what is theta? Theta is always the angle between the boundary at the boundary of water, oil, and solid, which is 1 point here, right? And this theta is always toward the denser fluid. This is very important. Theta goes always toward the denser fluid. Okay, water 99% of the times is heavier than our oil, so it could be different, but we assume in next few slides that water have higher density than oil. And in this case, the water density, when we measure the angle theta, we have to go always toward the water. So this is our theta. This is not our theta, because this is toward the oil phase, not toward the water phase. So this is not theta. Okay. Anyway, so if we write the force balance, we define a parameter which is called adhesion tension, and we show it with AT. And that's basically the difference between the oil solid interfacial tension and water solid interfacial tension. Now the force balance for this is pretty straightforward. That's sigma WS again, minus sigma OS plus sigma OW cosine theta is equal to 0, because there is a equilibrium there. So in that case, sigma OS minus sigma WS becomes sigma OW cosine theta, and this was the definition of adhesion tension. So adhesion tension is equal to sigma OW, which is the interfacial tension between oil and water, multiplied by the cosine of theta. Theta is called contact angle. Contact angle. So now this contact angle is a quantitative measure of the wettability of our fluid. So we use it to determine what type of rock we have. Do we have a water wet rock? Do we have an oil wet rock? And we can use also adhesion tension. Now, how do we compare this? How do we classify our rock? So look at this. If we have basically the contact angle between 0 to 30, we have a strongly water wet surface. So I'm gonna try to draw an example of that. So this is going to be our water. This is the solid surface, right? And we have oil here. Now, if I draw the contact angle, which is the interface between the oil and the water at this point, and I always for theta should go toward the denser fluid, which is the water. This is my theta, and this theta is between 0 and 30. Then this is a strongly water wet surface. Make sense? So this theta should be, so the water really spread over the surface, right? Now what happens, I'm gonna draw the same strongly water wet surface, but this time using an oil drop. Okay, so that's the same surface, solid. Now I'm gonna put a drop of oil. What do you think should be the shape of that oil drop? If my contact angle is less than 30, do you think that my drop should look like something like this? Oil? Or should it look like something like this? What is my contact angle? Should I go this direction or should I go this direction? This is water, right? All surrounding the oil drop. We don't go toward the lighter phase. We always go toward water. So this is our contact angle in this case. Okay, so these are the same thing. These two are the same thing. Okay, so the same contact angle, oil will try to squeeze as much as possible, make a sphere which has the lowest lowest volume per surface area, and this is also a strongly water wet surface. Now you can have moderately water wet. This angle could be 30 to 75 degree. You can have a neutrally wet, which is somewhere on average close to 90 degree contact angle, and then you can have an oil wet, which you have an angle basically usually more than 90 is considered to be an oil wet surface. So in this case, moderately oil wet is classified as 105 to 150 degree. So what does that mean? You have oil here spread over the surface, and then you have water. Again, your contact angle always go toward the then surface, which is toward the water, and this is, let's say, 150 to 180 degree. And in this case, this is a strongly oil wet surface. Now if you draw this by using just a bubble of water, then water stays like a spherical shape here, and oil is here. That's also a strongly water wet surface. Look at the contact angle again. Should I go this way or should I go toward water? I should go toward water, right? This is my theta, and that is 150 to 180 degrees. Okay, so that's the definition of contact angle and wettability. So theta is a quantitative measure of the wettability of our surface. Theta between 0 to 90 usually considered to be water wet. 90 is neutrally wet, around 90, and more than 100 or more than 90 depending is considered to be an oil wet surface. In the next video, we will talk in more details of water wet rocks and oil wet rocks and some other concepts.